All right, so last week your whole priority was to graph two graphs, or sorry, a line and then shade a region, right? So today what we're going to do is we're going to do much the same, except today we're going to graph two lines. And the answer is going to be a combination of two shaded regions in which it has to be true for both of these equations. Okay? So what happens here is this. All right, first of all, y is greater than or equal to x. All right, what's the first thing that we need to do in order to graph this? Make it an equal sign, right? Make sure my color stays consistent. Oh. Okay. Yeah, perfect, thanks. Okay, so now I've got y is equal to x. All right, so what's my starting coordinate?
0 and 0.
0 and 0, which is right here. And what's my slope tell me to do?
Up 1 over 1.
Up 1 over 1. Okay, now, solid line or dotted line?
Solid.
Solid, right. There it is. Okay, now, I've got to shade now. All right, now I can't use the 0 and 0 because it's on the actual line, so we know it's going to be true. So it doesn't help me with the region. So I'm going to pick another coordinate, any coordinate. Let's pick 0 and 1, that's right. So 0 and 1. So I put in 0 for x and 1 for y. Is 1 greater than 0?
Yeah.
Yeah, so I'm going to shade on this side of it. All right. Next equation is y is less than or equal to 4. So what does that line look like?
Shading 4. Yeah, horizontal.
Meaning?
Horizontal straight across on like y4.
Y equals 4, right? If I change this equation, it should say y is equal to 4. So where does y equal 4? 1, 2, 3, 4, right there, right? So does it matter what x is if y is equal to 4?
No.
No. So it's a graph, again, solid or dot?
Solid.
Solid because of the equals to. Okay. And now I need to shade the region that is less than y is equal to 4. Less than or equal to y equals 4. Press it. Y is less than or equal to 4. Where is y less than 4? Above that line and below it? Below it. So that's in this area here. So my solution then is somewhere where those two are combined. That's it. So if you pick any coordinate in this black and red region and put it into either one of the two equations, it will satisfy both of the equations. So example, let's pick this dot right here, which is 0 and 2. So I put it in here. 0 for x, 2 for y. Is 2 greater than or equal to 0? Yeah. So I put in 0, so I put 2 in here. Okay, I don't have the x value, so I put 2 in here. Is 2 less than or equal to 4? Yeah. So it's satisfied that you can pick any point in there. That's today. That's how it's different than last week. Last week you only graphed one line. Today you graphed two. Okay? We're good with this so far? All right. I have one other thing that I want to show you. So I'm going to use the y equals x, y is greater than or equal to x line. So I'm just going to graph the exact same thing. So I've got y is greater than or equal to x. Now, you're going to notice there are 4 possibilities of how to write this out. So it says y is greater than or equal to x, and it can say y is an element of reals, or sorry, x is an element of reals, x is an element of wholes, x is an element of integers. Okay, So we didn't talk about that last week. But you'll notice all of your graphs, like look on the page there, it says y is greater than or equal to x, x is an element of reals, y is an element of reals. Says the same thing for y is less than or equal to 4, x is an element of reals, y is an element of all reals. What this does, those three graphs, how it changes it. First of all, if it's an element of all reals, you shade everything. That means it can be negatives, it can be positives, it can be decimals, it can be fractions, it can be whatever. All right, so you shade everything for that guy. X is an element of all whole numbers. What are the whole numbers? Okay, one way to look, sure. What else? Be more specific though.
1, 2, 3, like nothing has to be on the lines.
Okay, so you're even closer to what I want, but you missed one very important one. 0. So it's 0, 1, 2, 3, 4, 5, 6. That's whole numbers, right? So if you do a question that says how many hamburgers and how many hot dogs, you can't have a portion of them. You're either buying a full hamburger or a full hot dog. So that means whole numbers. So what does that do to my graph? Well, it puts it only in the first quadrant. So that line looks like this, right? But I am only focused on the first quadrant here because it has to be whole numbers. So then when I shade on this, you notice they say shaded, or sorry, solid, dashed, or stippled, right? That's what it says on there. So the dashed represents not equal to, so that means just a greater than or less than. The stippled means that you have either whole numbers or integers, in which you would dot the line like this on all your whole numbers. So your shaded region, I'm making a mess of this, would look something like this. So instead of putting lines and shading it in, that's for the whole numbers. So if you see whole numbers, it tells you only the first quadrant. So you don't have to draw the rest of the graph. You just draw out your first quadrant. Okay? And you draw dots instead of shaded. Okay? Integers. How is integers different than this one? That's right. It can be a negative. So then my graph would look something like this. Okay? And you would put dots down. So instead of shading, you put dots down for these two guys right here. Now, for most of these questions, when you do the problems, most of the times it'll be a whole number. It'll say specifically. You can't have parts of a person. You can't have parts of a hamburger. You can't have parts of a hot dog. All right? When you're doing these questions, if you're doing a word problem, chances are it's probably whole numbers. Okay? That's all there is to learn today. So all you need to do today is on 5.2 is graph two equations now, shade their regions, okay? And then what I do is I actually would do this. I would go like this, so that I know that I would shade my second line, all right? And then I would change it to dots after. So even though I have the lines there, as long as I see that you understand that it has to be dots, that's fine. So shade both regions, and then if it says integers or whole numbers, then put dots. If it says whole numbers, make sure you erase everything outside of the first quadrant. Okay?
I'm on it.
Huh?
Yeah.
Sorry.
Okay? So
Please.
today,
Sorry, I'm having trouble with the connection.
Oh, that's
Please
nice.
try again.
so today today you shade 2. The one thing that I haven't done, I just want to make sure, is you finding the region. Equation, but I don't see it yet. Okay, so let's do one more example. Let's go to page 156. So we can do this together. All right, so on that graph paper I asked you to take out, let's do this question together. Graph the solution set for the following system of inequalities. State 2 possible solutions from the set. Check your work. 2x plus y is greater than 6, where x is an element of the whole numbers and y is an element of the whole numbers. All right. So what does that tell us when it says whole numbers?
Dots.
Dots and,
And it's
Just the one.
which means what?
Which means it's only the first quadrant.
First quadrant, that's right. So my question starts like this. Draw out your grid, and my grid I don't make the same size because I'm only using the first quadrant. That automatically sets my mind in motion to understand that I'm only in the first quadrant. 2x plus y greater than 6. First one. And the second one is that y is less than or equal to 3. All right. Okay. 2x plus y is equal to 6. How do I get y by itself? Subtract the 2x plus 6. Okay. What's my starting coordinate?
Oh, wait, never mind. That's just up.
0 and 6.
0 and 6.
Never mind.
How many of us in here still don't know how to find that starting coordinate? Be honest. Okay, it's your b value, right? Okay, so to ask you away, y equals mx plus b. Remember that from last year? So b is your starting coordinate because you put 0 in for x. To solve for y, so 0 times m is 0, add b is b. So that means when x is 0, y is equal to b. So when you have it in this form, y equals mx plus b, that b value is your 6. That's your starting coordinate. Okay, Amber, makes sense?
Yeah.
All right, now what's my slope tell me to do?
Down to right 1.
Okay, so I go down 2 and right 1. Just going to put it over here. All right. So far, so good? Okay, solid or dashed line?
Dash.
Dashed. Okay.
What are we doing? Oh, no.
Like that. Okay. Now that I have my line drawn, how do I find my shaded area?
2, 4.
Put a coordinate in. In this case, we'll put 0 and 0 in. So I put 0 in for x and 0 in for y. So 0 plus 0 is 0. Is 0 greater than 6?
No.
No. So I'm shading above this line, right? Now make sure you don't shade anywhere but the first quadrant. So it looks like that.
So why would you shade above it instead of underneath it?
Because this was, so if I pick any coordinate over here now, Brock,
Yeah.
let's say I pick 6 and 6 now,
Oh, okay, yeah.
okay, and I put 6 in here, that's 12, 12 and 6 is 18, 18 is greater than 6, so that means that any coordinate I find in this area makes that true. That's right, it'll make that greater than 6, okay? So now my next equation is y is less than or equal to 3.
So what?
So y equals 3. Solid line or dotted?
Solid.
So I go like that. And less than, is that above or below the line? It's less than 3, so where are all your y values that are less than 3? Below that line. So that's in this area right here, right? So there's
But only
my,
in the first, yeah.
there's my solution set. Okay, so far, everybody okay?
So that means we always have to do the first one, or like the first solution first.
No. No.
So you could do all the green across.
Yeah, you could.
But then only the.
Sometimes I would, sorry, go ahead.
Then only the stuff that's like mixed with the red. Yeah.
That's right.
That would be done.
That's right. So sometimes I would tell you actually to erase. It would be in your best interest to erase. So if I did all the green over here, or all the red, whatever, I would erase it after the fact so that I can just specify. But if I see lines crossing like this, then I know you've got it right. But,
Should we dot those as well? Or
exactly, how come?
because it's
Numbers.
Because it's whole numbers. So now all you do is you go back on and go to all your intersection points on your graph. Okay? So,
including on the line? No, not on the line.
no, not on the line. It can't be on that line, right? Because it's dashed or stick.
What about on the x-axis? Does that count or not? The axis will be 0. Right?
All right, so let's pick a point on there. Let's pick 0. So I put it in here. 16 is greater than, so it works for that one. And 0 is less than 3, so it works for that. So you would put it on here too. Okay. So is everybody following what we're doing there? Pretty straightforward, right? Your lines. Yes.
So you have to put it on the green line too?
Yeah, you can because it's equal to. That's right, Kosha. Put it right here as well. Those are all parts of this. That's right. Okay, so now that I have everything shaded, that's my thing's done. Like I'm done with this here. These guys right here. All right. I'm going to point this out right now because it's going to become a little bit more important to you as you go. These are called boundary lines. So wherever your shaded region is, this part right here, this part right here, and this part right here, those are all considered boundary lines because they are on the outside of the area that you have shaded. So they're all considered boundary lines. And these guys right here will eventually become important to us. Those coordinates there, what do we call them? They're vertices, but there's a very specific word for this. I'm make sure I got it. I can't remember what it's called. They're intersection points, but they are. I can't remember offhand. I'll find it by the end of the day. Okay, so basically, that takes care of 6.2 and 6.3. How many of you have Desmos or a graphing calculator here today? Who does not have the graphing calculator? You need it for tomorrow. And if you're going to download Desmos onto your phone, it's a free app. Get the test mode, okay? Because you're going to need it for tomorrow. All right. So make sure that has been taken care of by tomorrow's class, because we are going to use the calculators. Bless you. The calculators to use this. Okay. Let's see here. All right. Let's look at one last thing on page 157. Or, sorry, I didn't ask if there's any questions. Any questions on this? So the only thing different from last week is we're now graphing 2 lines, right? And the second thing is now we put dots instead of shaded area. Paige, go ahead.
So every time there's a dashed line, you don't put the whole number dots on it?
That's right, because it can't be on that line. It's not equal to that line. Okay? Yeah, Brock.
So why do you have dots on the
3 of those lines that are shaded and not.
I have dots on this line because it's equal to. I have dots on this line because it's my axis, so it's still whole numbers. I don't have dots on this line here because it's not equal to. So if all those lines were solid, I would have dots on all the lines. But if it has part like separation, if you have dashed, you don't put dots on it. Does that answer your question?
Yep.
Okay. Okay. So the last thing that we have to do, and this is the part that is going to cause some problems, is you have to make your own equations up based on the information given to you. So when you're solving problems now, you'll have to make the equations up, and that'll be part of the problem that you're going to have. So let's try and do this. To raise funds to buy new instruments, the band committee has 500 t-shirts to sell. The t-shirts come in red or blue. Based on sales of the same t-shirts at a fundraiser 5 years ago, the committee expects to sell at least twice as many blue t-shirts as red t-shirts. Okay, so the first thing you want to do, X, Y. All right, now there's a 4-step process to this that we're going to get into tomorrow, but for today I just need you to work through this. So I'm going to write out, first of all, what each of my things mean. So X is going to be red t-shirts, and Y is going to be blue t-shirts. Okay? So far, so good? So now I'm going to write a defining statement. So the first statement is this: how many t-shirts do I have total? So how would I write that in an equation to show that I have 500 t-shirts?
X plus Y equals 500.
Right, so I'd have X plus Y equals 500 in this case. So far, so good? All right. T-shirts come in red or blue based on the sales of the t-shirts at a fundraiser 5 years ago. The committee expects to sell at least twice as many blue t-shirts as red t-shirts. Okay, so there's the one. So I want to sell, how do I show twice as many, what is it, blue?
Y is greater than or equal to 2X.
Okay, Jason, go.
X plus 2Y, I don't know.
Okay, so I want to show twice as many blue as red. Okay, so if I make blue Y, how do I find out how many red there are? Or sorry, my bad. I'm going to start this a different way. If I make, so I've got X is red, correct? So how do I show twice as many X? 2X. Just make it 2X, right?
You did that with the Y, you tried.
So Y has to be greater than 2X. Okay, and this is what I said. This is how it's going to be confusing. So the committee expects to sell at least twice as many blue t-shirts as red t-shirts.
So couldn't that be an
Yeah, equal to, yeah.
Can be an equals to as well? At least as many, yeah. Okay, so easy way to do this. Not really. Not really. That's why it poses problems. But here's what I think about it. If I have one red t-shirt, how many blue t-shirts do I have?
half.
2.
2. If I have 2 red t-shirts,
Good.
how many blue t-shirts do I have?
4.
4. Does that make sense? Is there more blue than red by twice as much?
Yeah.
Yeah. So that's how I do it in my mind. If I'm struggling to figure out how to put that down on paper, then I say to myself, okay, I create a little mini table in my head and I say, okay, if I have one blue t-shirt, does that mean I have 2 red? Or does it mean if I have one red t-shirt, I have 2 blue? And then that's how I create the equation. This is the correct equation. So now I have to draw this out. Am I talking about whole numbers?
Yes.
Yes, I can't have part of a t-shirt, can I? So what I'm going to do then is I've got x plus y equals 500. So this is a perfect example, and when you have larger numbers, the best way to do the graph, is to use your intercepts. Because if I put 0 in for x, what is y? 500, so that's right here. And if I put 0 in for y, what is x? 500, that's somewhere down here. So I always do this, 0 and 500. 500 and 0. It's just a straight line. There's no shading actually for this guy. Looks like that. Okay, so that's what it would look like. Now the problem with this too is that's a large graph, and then you look at y equals 2x. I go up 1, right, 1, or so it's not as easy. So I go to 0 and 0 right here. Up 1, up 2 actually, bless you. Right 1 to here. Okay, so my next graph is going to look something like this, and it's a solid line. So I have that, but this one I have to actually shade now. Okay, so I can't use 0 and 0 because it's on the line, right? So I got to pick a point somewhere above it. So let's pick 0 and 2 then. So I put 0 in for x and 2 in here. Is 2 greater than or equal to 0? Yeah. So I'm now shading in this region, but because it's whole numbers, what should I do? Dots. Now, this is going to look ridiculous, but whatever.
Do you have to like make them look pretty if you're just like rounding it off?
Well, no, because you're on graph paper, right? So you see the intersections on the graph paper. So it's harder for me to do this here. And I also have to put them all the way up here. Okay? And there's my shaded area. That's done.
So you're graphing 2 lines on this thing, I guess.
Yeah. So these are my boundary lines right here. These are my critical points. I call them vertices. They're critical points. Okay? And then we'll get into where they intersect because those become important after the fact. But for right now, all I need you to do is be able to graph that right there.
You don't need to put it on the other side of the blue line?
Yeah, you could actually. Yeah, yes you could. Because this isn't a shade, this is just a solid line.
Yeah.
So you could put it over here as well.
So then what's the point of even writing that line?
To find that intersection point right here, that's the point of it. I'm just looking at the solution in here. The solution in here says that, oh, that's different graph. Never mind.
You need to go to graphing.
Now, their graph is different than ours because they used the equation where red was y and blue was x, and then they had 1/2, y equals 1/2. That's still going to give you the right answers. That's all said and done. So you can do it either way. Okay? So 6.2 and 6.3. 6.2 only has 5 graphs on it. So if you draw those 5, and then you should be on to 6.3 today. Okay, neither one is real long. 7 questions in that. Okay, is everybody back to where we needed to be from last week? We understand how to draw a line and shade down.
Did you videotape last week?
They're all online.
They are.
I put them on every day. Test was, of course. All right. Go to work then. 6.2 today, please.